So as Josh was just saying, what's distinctive about human intelligence is not just its speed or capacity, but our ability to go beyond the visible statistics of our environment to infer the hidden causes that explain what we see. So only one of these pictures of wildflowers makes you infer the presence of an invisible person. And similarly, when we see something complicated or surprising, the invisible cause we most often infer is another person, or at least another mind. So think about crop circles, or intelligent design, or my favorite, an Inuit word that means someone seen from afar off and blamed for otherwise inexplicable circumstances. So in a real sense, human intelligence is intelligence about humans. And correspondingly, if you look inside the brain of a human adult, you find that in addition to the older brain regions that we share with other animals, and that we use for seeing, hearing, feeling, and for controlling our movements, humans also have another distinctive set of brain regions that we're only discovering now through modern neuroimaging technology, and whose functions are specifically related to other people, to recognizing their faces and voices, seeing their actions, and understanding their emotions. And perhaps most surprisingly is the brain region I study, a small brain region above and behind your right ear, called the right temporoparietal junction, or RTPJ for short, whose function is specifically related to understanding other minds, people's thoughts, beliefs, desires, and intentions. These data come from a group we call normal human adults. They're MIT undergraduates. So this capacity to think about other people's minds is a distinctive feature of human intelligence. And it helps to explain why computers could beat human opponents at chess so many years before they could beat them at poker, and why a human 5-year-old child would still beat a computer at understanding the plot of Little Red Riding Hood. Or to give you another example that's maybe more World Economic Forum, compare what a computer does when it solves a complex differential equation that describes a financial market to what you do if you hear Alan Greenspan say, "I know you think you understand what you thought I said, but I'm not sure you realize that what you heard was not what I meant." So in all of these cases, the ability to understand another mind is the glue that binds together our societies, our social relationships, and our families, which is why its loss can be so devastating to children with autism and their families. So in my research, we're designing experiments that allow us to measure this human capacity. For example, we tell people stories. I'm going to give you an example right now. Grace is making a cup of coffee for her friend, and next to the coffee is a jar of a white powder, which is just regular sugar. But because the powder is labeled toxic poison, Grace thinks the powder is toxic poison, and she puts it in her friend's coffee. Was that morally permissible? So hopefully you think no, and most adults, when we ask them, say no, it wasn't permissible because she thought it was poison, even though it was really just sugar. And while they're making that judgment, we see activity specifically in this brain region. And the amount of activity in this brain region lets us predict which moral judgment they'll make. I'm also interested in how this brain region matures in childhood, because if you ask similar questions to children, you get different answers. 3-year-olds and even 5-year-olds will tell you there's nothing wrong with what Grace did because nothing bad happened. And it's not until children are 7 that they start to give the adult-like answer that it was wrong because she thought it was poison, even though nothing bad happened in the end. And even in adults, if we temporarily disrupt function in this brain region by passing a magnetic pulse through their skull with a tool called transcranial magnetic stimulation, we can temporarily change the moral judgments that they make, making them more like the younger children, shifting attention away from Grace's thoughts and intentions and towards the actual consequences. So recently, I've also been interested in how similar processes happen outside the lab, how we use our RTPJ to decide who's honest or dishonest, who to blame and who to forgive, or if something bad happens, who was responsible based on what they knew and when they knew it. I'm also interested in how we use the same systems to make decisions about our own actions, because recent research in psychology suggests that when people are deciding whether to cheat or whether to be corrupt, they're paying attention not only to the economic incentives or to the chance of being caught, but to what they think other people are doing, whether they think other people are doing it, and also to their self-concept, how the action will appear to themselves. And then finally, for me, the research challenge is to connect these questions with all the other themes in this issue, to understand how a group of neurons wired together in a connectome can construct something as abstract as the idea of another mind. Or on the other hand, what happens when you get many brains like this linked together, all thinking about each other? What new levels of complexity emerge? And that's the theme of the next 2 talks. Thank you.
Thank you. So